Hello, my dear students. Welcome to Math Exam Preparation channel. Today we are going to discuss Jacobians. This is a very important topic in the examination point of view, and also somewhat easy topic if you know the basics of partial differentiation. So this channel is particularly useful for those who are preparing for examinations. So I don't concentrate much on theory. We directly go to the practice. So let us take the definition of Jacobians in two dimensions. To define a Jacobian, we need at least two functions in two variables. Suppose u and v are two functions of x and y. Then the Jacobian of uv with respect to xy is defined to be a determinant given by dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Here the first row is all about u, that means partial derivatives of u in the first row. Second row is all about v, the partial derivatives of v in the second row. So most of the people confuse and write dou u by dou x and dou v by dou x here, right? So don't confuse that. So straight away I can go to problems. Before that, let us see some important basics or properties of Jacobians. So here we define or we denote this as J. Usually, because it is a Jacobian, we denote it by J. And you can also define, or if you can express u comma v as a functions of uv. Sorry. If you can express x and y as a function of uv, x as a function of uv, y as a function of uv, then you get the Jacobian of x comma y with respect to u comma v, and this is dou x by dou u, dou x by dou v. That means first row is all about x, right? Dou y by dou u, dou y by dou v. We denote it by j dash or j prime. Okay. In this case, that means from these two functions uv, if you can rewrite these two functions uv as x and y, that means if you can express x and y as a function of u and v from these two or vice versa, then this j and j dash have a property j into j dash equal to 1. So this is an important property of Jacobians. Okay. You have another property like of Jacobians. U is a function of xy, v is a function of xy, x and y are functions of r and s. Suppose x is a function of r comma s, y is a function of r comma s. Then in that case, so uv are functions of xy and x and y are functions of r and s. In this case, this is a chain rule. We have a chain rule. If you want to find the Jacobian of uv with respect to r comma s, what you can do? Jacobian of uv with respect to xy, first you find this, then you multiply this by dou xy by dou rs. So you want to get Jacobian of uv with respect to rs. It is Jacobian of uv with respect to xy and then multiply it by Jacobian of xy with respect to rs. This is called chain rule in Jacobians. This is another property. This is first property. So with these two properties, we can do problems in Jacobians. Let us take a problem. Suppose u is given as x plus y, v is given as x minus y, then prove that j into j dash equal to 1. So this is the problem. So how to solve this? U is a function of x and y, v is a function of x and y. So first let us find j. What is j? J is Jacobian of, suppose j is Jacobian of uv with respect to xy, which is dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So what is dou u by dou x? If you differentiate u with respect to x, what you get? The derivative of x is with respect to x is 1. Derivative of y with respect to x is 0. Right? Because it is independent of x. This is partial differentiation. Right? So the derivative of u with respect to x is 1, 1 plus 0, 1. Derivative of u with respect to y, when you differentiate this with respect to y, here the derivative is 0, here it is 1. So 0 plus 1, 1. Okay. And coming to second row, dou v by dou x. Dou v by dou x is 1 minus 0. Right? You differentiate with respect to x. So derivative of x is 1 minus 0. Dou v by dou y is derivative of x is 0 with respect to y. We are differentiating with respect to y. So derivative of x is 0. In the first term it is there is no x, there is no y, minus dou v by dou y is 1. So it is minus 1. So therefore the determinant value is 1 into minus 1 minus 1 into 1. It is minus 1 minus 1 minus 2. So therefore the value of j is minus 2. Now what is given? Here given u equal to x plus y and v equal to x minus y. Right? Now to find j dash, what is j dash? J dash is the reverse, dou xy by dou uv. It is not simply reciprocal. First we have to express x and y as a functions of u and v. So for that what you have to do is, you just add these two. What you will get? U plus v equal to 2x. From this you can write x equal to u plus v by 2. Right. Similarly, if you subtract, u minus v is 2y, y is u minus v by 2. Okay. Now you got both x and y. X is u by 2 plus v by 2. Y is u by 2 minus v by 2. Now you can find j dash. J dash is dou xy by dou uv. It is dou x by dou v, dou u, dou x by dou v. First row is x. Dou y by dou u, dou y by dou v. Right. This is, now we are differentiating x with respect to u. So in the first term we have u by 2. So derivative is 1 by 2 plus in the second term there is no u. So derivative is 0. Derivative of u with respect to u is 1. Right. So the derivative of x with respect to u is 1 by 2. Similarly, derivative of x with respect to v is, here it is 0, here 1 by 2 into derivative of v with respect to v is 1. So 0 plus half. Similarly, the derivative of y with respect to u is 1 by 2 minus 0. It is 0 minus 1 by 2. Derivative of y with respect to v is 0 minus 1 by 2. So finally what we got is 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. So determinant is 1 by 2 into minus 1 by 2 minus 1 by 2 into 1 by 2. It is minus 1 by 4 minus 1 by 4, which is minus 1 by 2. So therefore j dash is minus 1 by 2. Therefore what we have to do is j into j dash is minus 2 into minus 1 by 2. 2 gets cancelled, minus into minus plus, we get 1. Therefore j into j dash equal to 1 is proved. Now let us go to second problem. If u equal to x plus y square by x, v equal to y square by x. Then show that dou uv by dou xy is 2y by x. Okay. Solution. You are given u equal to x plus y square by x, v equal to y square by x. The Jacobian dou uv by dou xy, dou uv by dou xy, how can you write this? This is a determinant. Dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Right? So we have to find out all this. What is u? U is x plus y square by x. So therefore, what is dou u by dou x? Dou by dou x of x plus y square by x. The derivative of x with respect to x plus dou by dou x of y square by x, which is dou x by dou x is 1. Here we are differentiating with respect to x, and you have y square in this. You can take it as constant. So dou by dou x of 1 by x. Because y square is independent of x, then you can take it out. So here it is 1 plus y square into derivative of 1 by x is minus 1 by x square. So 1 minus y square by x square. Right? Now dou u by dou y. Dou by dou y of u, x plus y square by x. Here it is dou by dou y of x plus dou by dou y of y square by x. Right? Here there is no y in this. Completely the term is independent of y. The derivative is 0. Plus. We are differentiating with respect to y. So you can take any term or factor related to x out. So this becomes dou by dou y of y square. So 1 by x into derivative of y square with respect to y is 2y. So 2y by x. So this is dou u by dou y. Now dou v by dou x is dou by dou x of y square by x, which is, you can take y square out because we are differentiating with respect to x. Dou by dou x of 1 by x, this is minus 1 by x square, so minus y square by x square. Dou v by dou y is dou by dou y of y square by x, which is 2y by x, because 1 by x is constant. You keep 1 by x as it is, derivative of y square is 2y. So combining all this, we get dou u by dou v uv by dou x y becomes dou u by dou x is 1 minus y square by x square. Dou u by dou y is 2y by x. Dou v by dou x is minus y square by x square. Dou v by dou y is 2y by So if you take the determinant, this into this minus this into this, it is 1 minus y square by x square into 2y by x minus 2y by x into minus y square by x square. 2y by x minus 2y cube by x cube plus 2y cube by x cube, which is 2y by x. So that is the required answer. Okay. Let us go to another problem. If x is given as u into 1 minus v, y is given as uv, then prove that j into j dash equal to 1. We are given x and y in terms of uv, right? So therefore, here j becomes dou xy by dou uv. We can name this as j, right? Then it is dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. Right? What is x? U minus uv. What is y? uv. So therefore, dou x by dou u. We are differentiating x with respect to u. In the first term you have u. Right? So it is 1. Minus in the second term you have uv. We are differentiating with respect to u. So v is constant. Derivative of u is 1. So 1 minus v. From here also directly you can do it, because the derivative of, let us do like that. It is dou x by dou u is dou by dou u of u into 1 minus v, right? We are differentiating with respect to u, so 1 minus v is kept as constant. You can take it out. The remaining is u. So 1 minus v into dou u by dou u 1. It is 1 minus v. Okay. And dou x by dou v, we are differentiating with respect to v. So dou x by dou v is dou by dou v u into 1 minus v. Now we are differentiating with respect to v. So you can take u out. This becomes derivative of v with respect to derivative of 1 minus v with respect to v. U into, so derivative of 1 is 0, constant. Derivative of v with respect to v is 1. So it is minus u. It is minus u. Okay. And coming to uv, y equal to uv, dou y by dou u is v, because v is constant. Derivative of u is 1 with respect to u. And dou y by dou v, differentiating y with respect to v, here u is kept as constant. Derivative of v with respect to v is 1. Okay. So the determinant is finally 1 minus v into u minus v into minus u. V into minus u. It is u minus uv plus uv, which is u. Therefore, J value is u. Jacobian of xy with respect to uv is u. Now, to find J dash, we are given x as u minus uv, y as uv. Okay. We add these two, we get x plus y equal to u, because minus uv plus uv gets cancelled. So from this, you got u as a function of x plus x and y, right? And we are directly given y equal to uv. We want to find v, right? So v is y by u, and y by, we already got u, which is x plus y. So therefore, v is y by x plus y. Okay. So therefore, Jacobian of uv with respect to xy is dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Now what is dou u by dou x? Dou by dou x of u. What is u? U is x plus y. Again, derivative of x with respect to x is 1, and there is no x in the second term, derivative is 0. Similarly, dou u by dou y is 0 plus 1, which is 1. Now, dou v by dou x is dou by dou x of v. V is what? Y by x plus y. Y by x plus y. We are differentiating with respect to x. In numerator there is no x. So you can take y as constant, dou by dou x of 1 by x plus y. But what is the derivative of 1 by x minus 1 by x square? Derivative with respect to x. So here this is like 1 by something. Derivative of 1 by something is minus 1 by something square into derivative of that something with respect to x. We are doing with respect to x. Okay. We have to write dou by dou x here. Now this is minus 1 by x plus y whole square into 1. So minus 1 by x plus y whole square. So this is dou v by dou x. Similarly, dou v by dou y. Dou by dou y of y by x plus y. Here in the numerator and denominator, both involve y. So we have to use the derivative of u by v. So first of all, denominator square, denominator into derivative of numerator minus numerator into derivative of denominator. Okay. So that is u by v. It is x plus y whole square, x plus y into derivative of y with respect to y is 1, y into derivative of x plus y with respect to y is 1. Okay. 0 plus 1, 1. X plus y minus y by x plus y whole square. Therefore, dou v by dou y is x by x plus y whole square. Therefore, J dash is 1, 1 minus y by x plus y whole square, y by x by x plus y whole square. Now this is Jacobian determinant is x by x plus y whole square minus y by x plus y whole square. So denominator is x plus y whole square is the LCM. In the numerator it is x plus y. 1 x plus y gets cancelled. It is 1 by x plus y. But what is x plus y? It is u. So it is 1 by u. Therefore J dash is 1 by u. And what we are asked to find or show that it is j into j dash equal to 1. We got j as u and j dash is 1 by u. So it is 1. Hence proved. Okay. Now the coming problem is somewhat more important than the previous. If x equal to e power u into secant v, y equal to e power u into tan v, then show that jj dash equal to 1. So how to solve this? We are given x and y in terms of u and v, right? So j, you name it as dou xy by dou uv is named as j, dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. This is, see, we are differentiating x with respect to u. When you differentiate x with respect to u, secant v is constant, derivative of e power u is e power u. Right? So, e power u secant v. Secant v is constant, derivative of e power u is e power u. And dou x by dou v, differentiate with respect to x with respect to v. Now e power u is constant, derivative of secant v is secant v tan v. So e power u secant v tan v. Okay. Similarly, derivative of y with respect to u. Here tan v is constant, so derivative of e power u with respect to u is e power u tan v. When you differentiate y with respect to v, e power u is kept constant, derivative of tan v is secant square v. Okay. Therefore, it is, we take the determinant e power u secant v into e power u secant square v minus e power u tan v into e power u secant v tan v. It is e power u into e power 2u secant v into secant square v secant cube v e power 2u secant v into tan v tan square v. So you can take e power 2u common and also secant v common. We get secant square v minus tan square v, which is 1. So e power 2u secant v is j. Therefore, j is e power 2u secant v. Okay. Now we have to find j dash. To find j dash, we are given x equal to e power u secant v and y equal to e power u tan v. From this we have to find u and v, right? So how to find? We know the formula secant square v minus tan square v 1. So you consider x square minus y square e power u secant v square minus e power u tan v whole square. So e power 2u secant square v minus e power 2u tan square v. You take e power 2u common, we get tan square v. It is e power 2u into 1. So therefore, x square minus y square is e power 2u, or 2u equal to e power 2u equal to x square minus y square. You take logarithm on both sides, you get 2u equal to log x square minus y square. So you got u equal to 1 by 2 into log x square minus y square. Now to find v, you divide x and y. E power u secant v by e power u tan v. Why? Because e power u gets cancelled. Okay. Now there is no u term in this. Now this is secant v by tan v. Secant v is 1 by cos v. 1 by tan v is cot v, which is cos v by sin v, which is 1 by sin v. So sin v, 1 by sin v is x by y, sin v is y by x. So v is sin inverse y by x. This is v. This is u. Now we got u and v both. Okay. From this we have to find j dash. So what is j dash? Dou uv by dou xy, which is dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So what is u? 1 by 2 into log x square minus y square. So what is dou u by dou x? We are differentiating u with respect to x. Okay. And what is the derivative of log something is 1 by something. Whatever is there in this bracket, it comes here. Okay. So it is 1 by 2 is constant. You write as it is. Log something derivative is 1 by something into derivative of this something. Derivative of something. So which derivative? Dou by dou x of x square minus y square. Okay. Now, what is the second one? Dou u by dou y. Dou u by dou y is, we are differentiating this with respect to y. 1 by 2 constant. Log something derivative is 1 by something into derivative of something with respect to y. Now dou v by dou x. What is x? What is y? V. V is sin inverse y by x. The derivative of sin inverse y by x. What is the derivative of sin inverse y by x? What is the derivative of sin inverse x? This is 1 by root 1 minus x square. Okay. So sin something derivative is 1 by root 1 minus something square. Something means here x. The something means here y by x. Okay. Here the something is y by x. So derivative of sin inverse y by x is 1 by root 1 minus that something square into derivative of something. Here dou v by dou y is again sin inverse something derivative is 1 by root 1 minus something square into derivative of something with respect to y. Here with respect to x, here with respect to y. Now this is, if you simplify, you will get x by x square minus y square minus y by x square minus y square minus y by x into root x square minus y square 1 by root x square minus y square. If you take the determinant, what you will get? X by x square minus y square whole power 3 by 2, because root x square minus y square is nothing but x square minus y square whole power half. Right? Minus y square by x square minus y square whole power 3 by 2 into x also comes in the denominator. So if you take the It is x square minus y square whole power 3 by 2 into x. In the numerator you get x square minus y square. So it is 1 by x root x square minus y square. Okay. Now coming to j into j dash, it is e power 2u secant v is j. We got this as j, right? Into 1 by x root x square minus y square. So either we have to convert this into this in terms of xy or this in terms of uv to simplify this. Okay. Now let us convert the second one into u in terms of u and v. It is e power 2u secant v into 1 by x is e power u secant v and x square minus y square is e power 2u, right? So this is e power 2u secant v by e power u secant v into e power u. E power u into e power u, e power 2u. Secant v gets cancelled, e power 2u gets cancelled, 1. So therefore, j into j dash is 1 again. So these type of problems are very important. Okay. With this, I stop here the Jacobians of two variables. So these are all the problems based on Jacobians of two variables. But still we have some more problems. Those are very important problems. There Jacobians part 2 will be there. Jacobians of three variables is also there. After that we have functional dependence and independence also. That will be another video. Okay. Thank you.